Now we will go in the wavelength scan mode, and here we will set our scan parameters from 350 to 200 nanometers, and we will select a reading for every wavelength. We will take readings, and we will try to superimpose 5 scans which will correspond to two different concentrations of our sample. So after setting these parameters, we will confirm, and this is the menu where we can, by clicking the right button of the mouse, first step is to set the instrument for 0 on complete range of wavelength, which is 350 to 200 in this case. So I will ask the instrument to set all the wavelengths to 0, and at this time I have placed the solvent of my sample in the sample compartment. The instrument will acquire the baseline or with the solvent in which our sample is dissolved. So here we have selected wavelength range from 350 to 200. So now the instrument is performing 0 at all wavelengths from 350 to 200. This message baseline has been established indicates that instrument has acquired or zeroed the absorbance values for all the wavelengths from 350 to 200. Next step is I will verify the nature of the baseline the instrument has acquired. So I will place the same solvent in the sample compartment and will press the start key. Now if instrument has corrected the baseline and zeroed absorbances at all wavelengths, we will get a straight line at 0. We can see here in the chart that at all wavelengths the third digit is approximately 0. So we can take it like instrument has done the auto zero function to our expectancy. We are almost getting all zeros at third place of our absorbance display for the entire wavelength range we have selected, which is around 350 to 200 in this case. Next step will be, after acquiring this baseline, we will be placing different strengths of our samples for spectrum acquisition. So for blank or solvent, it has acquired the spectrum. Next step will be, I will be placing the sample of certain concentration in the sample compartment and will press start. So next will be, the instrument will be acquiring the spectrum of our sample in the range 350 to 200, and at the same time it is showing the absorbance values at a interval of 1 nanometer. It will show all the values. Here you can see in ABS2 we are getting all values at increment of 1 nanometer. In the parameter setting, we have selected scan times 5. So here we can overlay 5 spectrums or of different sample of different strengths or concentration. So this is the first one is going. Now I will change the concentration of the sample. I have placed a sample of different slightly lesser concentration in the sample compartment, and I will repeat the procedure for acquiring the spectrum of the second concentration. As you can interpolate from the graph that the strength of the second concentration is slightly less than the first one, and correspondingly you are getting slightly lower values for the second spectrum. Here we can overlay 5 different strengths of concentrations of the sample. Now I have placed a third third sample of slightly lesser concentration, that of sample second. So accordingly I can see from the table that the absorbances values are relatively less than that of second one. Now I am placing the last fourth sample of slightly lesser concentration, that of sample 3. we now all the scans of three three samples of four samples of different concentrations, samples of DNA of different concentration, and one of the solvent has been acquired. And here we can get all the absorbances values at different wavelengths, but as we can choose any wavelength which is of importance to us, like 240, 260 and 280 in the case of the DNA purification analysis. And the next step is the storing of the spectrum. We can has the option to save as per our file name, whichever format we wish to store, and we can select any directory of our interest. And most appropriate way to store and recall is to store in the format year, month, date, nature of the sample. Say here it is DNA, and for reference we can give the wavelength range in which we have analyzed. So by storing in this format, we can at any point of time in future we can interpret and can understand the date on which our analysis was done, and the nature of the sample, and the wavelength range in which it has been acquired. So this is the format which we recommend. Now we can save this. So this is this is the spectrum, and suppose if we want to acquire the report of the analysis, so this is the format we will get in the on the printer. So in brief, what we did was we have used the wavelength scan mode of our instrument software, and have defined the wavelength range in which we wish to acquire the spectrum, and the wavelength interval for which we want the absorbance data, and the number of scans of different strengths which we want to overlay for our interpretation. And then after acquiring the spectrums, we have taken the printout, which comes out to be in this format with absorbances at different wavelengths.